Okay, let's unpack this. We've got a document here detailing Ontology's decentralized identity framework, right? ONT ID.
Yep, that's the one.
And this isn't just the usual overview. It's a technical specification, straight from their developer center, laying out the precise rules, how it all works.
Exactly. It's the technical method specification.
Yeah.
Really gets into the nuts and bolts.
Yeah, and here's where it gets, well, really interesting for me. This document outlines, everything. How these ONT IDs are created, registered, managed, all the way down to the different bits and pieces that make up your digital identity document in this system.
So what does this actually mean for you, the listener? Our mission here in this deep dive is to take this, well, dense spec and translate it.
Make it make sense.
Yeah, into a clear explanation. We want you to get what ONT ID is, fundamentally, how it works under the hood.
And why the details matter, right?
Exactly. Why these specific technical choices are important if you care about digital identity, about actually owning your data.
Yeah.
We're trying to get past the buzzwords here.
Show the concrete architecture. And the core promise coming right from this source doc, it sounds pretty compelling. Decentralization, self-management, privacy protection, ease of use.
And giving the user complete control, built on standards like W3C DIDs, blockchain, crypto.
All the key ingredients.
So let's dive into those specific technical details, the ones meant to actually deliver on those big promises.
Okay, let's start right at the core. What is an ONT ID, technically speaking, based on this spec?
Yeah, the definition.
It's defined as Ontology's framework, blockchain, and crypto-based for decentralized identity. And it's designed to instantly identify and connect pretty much anything. People, assets, things, events.
Got it. And it's not built in a vacuum, right? The source says it's based on and extends the W3C DIDs specification.
Yeah, that's crucial. It ties into a bigger standard, which is good for, interoperability down the line.
Makes sense.
Now, the actual format, the identifier string itself, every ONT ID starts with did.ONT. Right, that it did. Prefix signals it's a decentralized identifier, and ONT is the method. Ontology's method. What about the unique string after that?
That's the ONT ID string, and the spec is really specific about how it's made. You start with a 20-byte random number.
Okay, randomness.
Add a 1-byte tag, then you double hash that whole thing using SHA-256.
Double hash. Why twice?
Likely for added security or compatibility with specific crypto conventions they use.
Yeah.
SHA-256 is a standard strong hash function. Creates that unique fingerprint. Then you take the first 4 bytes of that final hash as a checksum.
A checksum for error detection, if someone mistypes it.
Exactly. So it's not just random. There's a specific cryptographic recipe. Random number, tag, double hash, checksum. It ensures uniqueness and lets you check the integrity.
Okay, that makes sense. And then
all that binary data, the random part, the tag, the checksum, gets encoded into a base 58 string.
Base 58, I've heard that mainly with Bitcoin addresses and stuff. Why use that here?
Well, base 58 is clever because it avoids characters that look alike, like the number 0 and the capital O, or capital I and lowercase l.
Ah, right. So it makes it less likely you'll screw it up if you're copying and pasting it or even reading it out.
Exactly. It seems minor, but for IDs that need to be precise, it really helps usability, reduces errors.
Okay, so usability driving that choice. Makes sense for something potentially long and complex.
Precisely. And they give that example. Did.adders, AEXSY, ASEE, AUHEXE, AWeaver, AULKMU, A51, I2CD is G72. The string after did.09 is that base 58 result.
Got it.
This spec also mentions, briefly, that this ONT ID can work like a URL, following standard DID URL rules. So you can add parameters or paths to point to specific parts of the identity info.
Okay, so you've got this unique ID string, generated carefully, formatted for usability, but it doesn't just, float around. It has a life cycle, right? Activation, deactivation.
Absolutely. And this is critical. An ONT ID must be registered on the Ontology blockchain to be activated.
Ah, so the blockchain step is what makes it live and decentralized.
Precisely. That registration puts it on the public ledger. It anchors its existence, makes it verifiable, and it stops anyone else claiming that same ID. The spec is super clear. The same ONT ID must not be registered more than once.
Uniqueness enforced by the network itself. Good. What if you're done with it? Can you delete it?
You can deactivate it, but only the owner or someone they've specifically delegated control to can initiate that.
Okay, owner control.
And when it's deactivated, the specs says all the associated data in the identity document keys, delegates, attributes, recovery info, it's essentially wiped or marked inactive. Only the identifier itself stays on the chain, but it's marked as deactivated.
And once it's deactivated, can you bring it back?
Nope. According to this spec, A deactivated ONT ID cannot be used anymore, and crucially, it cannot be reactivated. It's permanent.
Wow, okay. That's a definite choice. Permanence.
Yeah.
So moving on from the ID string and its life cycle, let's talk about the actual identity information, the ONT ID document.
Right. The spec describes this as the standard way to serialize all the info linked to an ONT ID. Uses JSON based on that W3C DID standard.
So this JSON document is the digital representation of the identity.
Pretty much. It's where all of the critical stuff lives. Configuration, control logic, relationships. Let's walk through the key properties mentioned.
First one, at context. We see this in linked data stuff. What's its job here?
Think of it context like a dictionary. It tells systems what the terms used in the document mean. It's vital for making sure different applications can understand the data correctly.
So it points to definitions.
Exactly. The spec says it must link to the standard W3C DID definitions and also to ontology-specific ones for their extensions. But the powerful part is it also lets you link to your own custom definitions via URIs.
Wait, so if I want to add like a favorite color attribute to my identity, I can define what that means somewhere else and link to that definition using it context?
Precisely. It makes the whole thing extensible. You can add custom stuff, but the standard parts remain understandable. Very flexible.
Okay, cool. Next is UD. That seems simple enough.
Yeah, this one's straightforward. It just must be the ONT ID that this document is describing. Like our example did ont.adders, adders, rs, sys, sfeo, geo, chi, vlk, moi, 51, i2c, does esg72. It's the root identifier.
Then we hit public key. Keys are obviously fundamental in these systems.
Absolutely critical. This property is mandatory. Public and private key pairs are how you control things, authorize actions, prove who you are cryptographically.
Makes sense.
An ONT ID can have multiple key pairs linked to it. And, interestingly, one key pair can actually manage multiple ONT IDs.
Oh, that's flexible. One key to rule multiple identities.
Potentially, yeah. The spec says the owner's main public key should be bound when the ID is registered.
Yeah.
And obviously, the owner must keep that private key safe.
Obviously.
Each key listed under public key needs details. It should have its own ID within the document, like hashtag keys 1. It needs a type that's the crypto algorithm, like ECDSA, EDSA, standard signature stuff.
Right.
And it needs a controller. This must be a valid ONT ID. Crucially, it's the ID that controls the private key for this public key.
So the controller says who wields the power associated with this key.
Exactly. It also lists the encoding format for the public key string itself, like hex or base 58, just different ways to write down the key data.
Okay.
Oh, and it notes that keys can be revoked permanently, but they keep their serial number, like hashtag keys 1. The example shows a typical entry.
Got it. Now, there's also an authentication property. How's that different from just listing keys in public key?
Good question. Public key is the master list of keys associated with the ID. Authentication, which is optional, specifies which of those keys, or maybe other methods, are specifically allowed to authenticate as the identity holder.
Ah, so it's like the approved login methods.
Kind of, yeah. Which keys can be used to prove it's really you interacting? The example shows you can either just reference a key from the public key list by its ID, or you could even embed the whole key object right there in the authentication section.
Okay, so public key is the inventory. Authentication is the allowed to use for login list. Makes sense. What about the controller property at the main document level? You mentioned delegation earlier.
All right, this is where that comes in. Also optional. This designates who has the overall control over the ONT ID itself. By default, if you set it up yourself, you are the controller.
Self-sovereign?
Exactly. But you can delegate control to another ONT ID or even a group of ONT IDs. And if you want to delegate, you must specify that delegate when you first register the ID.
And what can this controller actually do?
They get significant power. They can register or deactivate the ID, and crucially, they can modify the public key and authentication properties.
Whoa, so a delegate could add or remove keys, change who can log in or manage settings?
Yes, that's why delegation's a big deal. You're trusting them with core control. The spec also mentions a delegate can technically add the owner's key back to make it self-managed again. But once it's self-managed, you can't switch back to delegated mode.
Interesting constraint. And you said a group could be the controller. How does that work?
Yeah, this is where it gets really sophisticated. Management groups with threshold logic. You can list multiple members, other ONT IDs, maybe even nested groups, and set a threshold, say threshold 2. Meaning you need valid digital signatures from at least 2 members of that group to authorize an action.
Wow, so you could set up like a 2 of 3 multi-sig control. Or require approval from, say, both legal and finance departments represented as ONT IDs.
Exactly that kind of thing. It
Mhm.
allows for really flexible multi-party control. Think corporate identities, shared assets, DAOs. The example shows this. Controlled by IDA or R, a group needing two signatures from IDB and IDC. Any operation needs signatures that match this logic.
That level of granular programmable control built right into the identity structure.
That's powerful.
Okay, what about recovery?
Losing keys is a nightmare.
It is. So this is another optional property. It lets you designate a recovery party, someone who can help if the main controller, especially in a self-managed setup, loses their private key.
A backup plan. Kind of. Importantly, only a self-managed ONT ID can set a recovery party. You can't have both delegation and recovery set up simultaneously, it seems.
Okay, so if I lose my key, what can the recovery party do?
The recovery party, which again can be individuals or groups with thresholds, just like the controller gets specific limited powers. They can help reset the key situation. The spec says they can add or delete keys from the authentication list, and they can update the recovery settings themselves.
So they can add a new key for me to use, essentially.
That seems to be the implication, yes. Help you regain control by managing the authentication keys? The example shows a recovery setup with thresholds. One, meaning either of the two listed recovery IDs can initiate the process. Think social recovery, maybe?
Yeah, or nominating a trusted third party. Provides a safety net without relying on a single central help desk. Okay, service property, what's that for?
Optional again. Lets you link services related to the ONT ID. Typically includes a type for the service and a service endpoint URL.
Like pointing to my decentralized social media profile, or maybe where my encrypted data backups are stored.
Exactly like that.
Yeah.
It lets others discover services you've associated with this identity. The example shows linking a some service type to a specific URL endpoint.
Simple enough. And then attribute.
Yep, another optional one. This is for adding extra, sort of, custom properties directly to the ID. Owner or delegate can manage these. Each attribute needs a key, a value, and a type.
So this is where you might put things like a display name or maybe a verified claim like over 18.
Could be.
Yeah.
The spec notes the application layer really defines the types and content.
Yeah.
So it's flexible. It gives examples like key, age, type, number, value, 18, or just generic ones. But there are limits, max 100 attributes, size limits on the key value type fields. So it's for structured but fairly compact data.
Gotcha. Not for storing huge files. And lastly, timestamps and proof.
Right. Created and updated timestamps should be included. Standard ISO format. Shows when it was registered and last modified. And then there's proof. This may be included.
To prove the document itself hasn't been tampered with.
That's the idea, yeah. Probably a signature over the document content. But, interestingly, the spec explicitly says this proof property wasn't fully implemented when this document was written.
Huh. Okay, so it's a placeholder or future feature noted in the spec?
Seems like it. Shows it's an evolving standard.
Yeah.
But yeah, summing up, the ONT ID document is this comprehensive JSON structure. It ties together keys, control logic, recovery options, linked services, custom attributes. It's the whole package for your digital identity on their network.
When you lay it all out like that, all these specific features from the spec, the crypto ID, the blockchain registration, the really granular delegation and recovery stuff, you really see the kind of detail control ONT ID aims to give the owner.
And connecting this back to you, the listener.
Yeah.
Understanding how these pieces are defined, the controller thresholds, the recovery mechanisms, it helps you appreciate what user-controlled identity actually means under the surface.
Yeah, it's definitely not the same as just having a username and password controlled by some central company.
Not at all. It highlights that fundamental difference.
Absolutely. Which, leaves me thinking, given this level of complexity, this flexibility that's explicitly designed into the identity components right here in the technical spec, what completely new ways of interacting online could this enable? What kind of collaboration or even shared ownership of digital things becomes possible when identities are built with this kind of deep, decentralized control and relationship mapping baked right in?